if you have any questions that you'd like to ask me regarding the program or about functionality, just write it down and then just send it to us through an email at the end of the session. And then we can get back to you and answer your questions individually. Okay. So before I get into the modeling portion of this presentation, what I'll do is I'll just give a brief introduction to our company, Midas. I know we have several sort of users here already, but for those of you who are new to our company who haven't heard much about us yet, I just want to give a brief introduction so that you know sort of our background and the services that we can offer for you. Okay, so Midas IT, which is our headquarters, is headquartered in South Korea. Currently, the total company size globally is about 450 engineers, and we were established in 1989. Currently, we have a worldwide existence, so we have sort of main regional offices in the United States, in India, China, Japan. We have another one that will be established, or has been established actually very recently in Russia, as well as the United Kingdom. Currently, I'm broadcasting from our New York office in downtown Manhattan, and currently we cover all of North America as well as Latin America. Okay, so we have a total of 6 branch offices, 25 resellers, and 100 export countries. So essentially, you know, our software is used around the world. So our software is used, you know, around the world, and we're continuing to grow. So as, you know, for those of you who worked overseas, you know, I'm sure, especially in Asia, you know, our software is used quite frequently. Especially here in the U.S., it's really starting to become used more regularly, especially with many of the state DOTs. Okay, and as far as the companies that we work with, you know, these are some of our major clients. Many sort of industry leaders use our software regularly, both for their bridge software as well as their geotechnical or structural applications. So we can hope to continue to, you know, sort of expand sort of the range of clients that we have. And hopefully, for those of you who haven't, who don't currently own copies of the program yet, hopefully this seminar, this lecture will be a good sort of introduction to help you understand how the software could be of use in your own office. Okay, and then for those of you who aren't familiar with the other sort of Midas programs or the other suites that are available, we currently have a program called Midas GTS for geotechnical engineering, Midas Gen for building and general structures. Midas Civil, which is what we're going over today, is specifically for bridge structures. I'll go over you know, some of the main features or some of the unique features of Midas Civil as we go over the presentation. Then we also have Midas FEA, short for finite element analysis, which is for advanced nonlinear structures. So this is sort of a higher end finite element analysis tool for very detailed sort of modeling. And of course, we have Midas NFX for mechanical engineering. So if anybody has any questions about these other programs, feel free to, you know, contact us, and we can get you started with maybe an evaluation license, or we can have a sort of an online meeting to help you get introduced to the program. Okay, so one of the things that really sets Midas apart from the other companies or other software or engineering software companies is the extent that we go to for training. So something that we, you know, sort of understand is that when you're sort of learning a new program, or even if you're using a program that you've been using for a while, there's still come, you know, many opportunities where you might need sort of technical support or training. So this is something that we're always striving to offer to not only our clients, but also to engineers who are just new to finite element modeling in general. So if you look to the right here, as you can see, we have a couple of pictures from a bridge seminar that we recently held in New York City. Sort of many companies from around the tri-state area came and visited to see sort of what was possible with our programs and what was possible with finite element modeling. And of course, we also have many events around the world. We're from Italy, the United Kingdom, the Netherlands, and then Asia, for example, Japan, China, Indonesia, and Korea. So, you know, we do have a couple of other sort of bigger seminars coming out later in the fall, and you should be receiving the invitations shortly if you haven't received them already. So we definitely encourage you to come. They're great opportunities to learn about you know, new technology that's being introduced in engineering, specifically bridge engineering. It's a great way to network as well. So the main thing to remember about these training sessions is that they're free. You know, we don't charge for our training. They're interactive, so, you know, there's a sort of a question and answer session for most of them. This is a larger sort of session, so the question and answer section will have to be sort of, we'll have to wait till the end. And then they can be customized as well. So something that's, you know, also very important to us is making sure that our clients get services that are specific to their needs. So this is what's called a general webinar. So, you know, we have, you know, I think roughly about 100 engineers attending right now. So this is just going over very general sort of functions of the program. But for example, if you have a very specific project type in mind that you want to go over, or if you're one of our clients and need specific project support, we can easily arrange a one-on-one online session to provide you with the support or the direction that you need in order to make sure that you're able to use the software to its fullest capabilities. So just keep that in mind. If you decide to pick up a sort of a program or one of our sort of licenses or packages, you won't just be purchasing a software. You'll also be sort of purchasing, or you'll also be guaranteed or provided training that will help you to use that software to its best abilities. Okay, and here are a couple of our clients who have shared sort of online sessions for us in the past. So I'm sure all of you have received the webinar invitation for the 27th. C.Y. Young of Michael Baker will be talking about the network tied arch bridge. So this seminar specifically is sort of an introductory seminar that will help you to sort of, I guess, maybe better understand what he'll be talking about on the 27th. So he'll be going to some more advanced sort of concepts. What I'll be going over is just the basic principles of modeling. So moving on now, what we'll do is we'll go into the demonstration itself. So this here is just a completed sort of version of the project. This is what our arch bridge will look like once it's completed. So this isn't the exact same arch bridge that C.Y. Young designed. This is actually one of our tutorials, but it has many similarities. As you can see, it has the arch bridge pattern. And let me actually turn on the view here. Okay, as you can see, it has the arch pattern, and it also has these hangers as well as stringers. So basically, what I'll be going over today is just how to model this structure, how to create your boundary conditions, and also how to input your dead as well as your moving loads. Then another thing that we can do, for those of you who are currently evaluating the software, I know there are several of you right now who are sort of using the evaluation license. If you're interested in modeling this particular project yourself, what we can do is we can provide you with a tutorial that goes sort of step by step in how to create this model. So, as I said, this week, or today anyway, we'll just be going over the basic modeling, and then in the week to follow, what I'll be doing is I'll be going over seismic loading, as well as how to use the new steel design module, which are both, very useful functions. Okay, so now what I'll do is I'll open a blank project file, and we'll just start from the very beginning, just how to create a particular model. So before I go into the modeling sequence itself, and let me move this tree menu here. Okay, so before I go into the modeling sequence itself, what I want to do is I just want to go over the basic sort of format of Midas Civil. So if you look sort of to the top portion of the screen here, this is what's called a ribbon menu. So each of these icons here contains a specific command. And as I create the model, you'll sort of get a better understanding what these commands do and sort of how they're organized. Just keep in mind that these list of tabs over here, going from left to right, structure, node element, etc., each of these corresponds to a different ribbon menu. So essentially, when you're creating your model, what you'll be doing typically is you'll be starting from your left, you'll be working your way to the right as you create your model, and then you'll do your analysis and you'll go over your results. So typically when you're going through the modeling, you'll stick around this area mostly, so you go over structure, node element, your properties, boundaries, loads, etc. And then after you run your analysis over here, you'll go over here to your results section and we'll go over the results. So, I know there are a lot of icons, but, don't be intimidated. Once you see me sort of using the program, you'll sort of get a better understanding of how really simple it is to sort of navigate through these different icons. Now, if you look over here to the left, to the far left, this is what's called the works tree menu, which is actually one of the defining sort of functions of the program. One of the great sort of features of Midas Civil is that it has what's called an interactive sort of work tree menu that organizes and sorts everything that you create. So for those of you who have, a lot of experience with numerical modeling, especially 3D modeling, you'll know that there's a lot of data sometimes that needs to be sort of taken into account before you can run your analysis. Well, what this workstream menu does is it lists everything that you create and organizes them very seamlessly. And then, so right now, I don't have anything created, so all this is blank, but you'll see as I make progress with my model, this will slowly become populated. And it'll be very easy to sort of sort through my model, my workstream menu, and select specific elements to go back and make sure that certain parameters are set, etc., etc. Okay. And then if I go to the bottom here, this is what's called the message window. Essentially, whenever you type in a command or whenever you do a command in Midas Civil, if it goes through, it'll be recorded here in this message window. And this message window is also very important. For example, if there are any sort of errors or there are any sort of warnings that come up, it'll appear over here. And of course, this center portion here is just the work or the model window. And if you go to the top right here, as you can see, this is your coordinate system. You can click on these arrows here and these tabs to sort of change your view. And then these icons over here control your display, or excuse me, your view settings. I'll go over these a little bit later. And then these options over here are just your selection filters that allow you to select certain elements or to unselect things, etc. Okay, so it's still, and I understand it's a lot to sort of go take in right now, but as you see me create the model, you'll see that it's very easy. It's very sort of intuitive as far as the way everything's set up. Okay, so before I actually create any sort of elements or any materials, the first thing that I need to do actually is define my material and my structural properties. So first, let's go to the Properties tab right over here. And then let's go to this icon here, Material Properties. So open this up. And when you select that icon, as you can see, this particular input menu comes up, and you'll have three tabs: Material, Section, and Thickness. So currently, for this project, since simpler, sort of a smaller scale conventional project, you only need to focus on material and section properties. So as you can see, I don't have anything listed yet, but if I'd like, I can click on Add here, and another input menu will come up. And what I can do is I can create, or I can select a specific type of material property. So for example, let's say I have like a steel type I don't want to use for my project. Just type in steel, I don't know, it's steel 1. As you can see, the default is steel, but I can select between concrete, steel reinforced concrete, or user-defined material. Under the standards, all of my major standards are listed. So let's say I want to use ASTM-S and the database, and as you can see, I have all my different steel types listed here. Same principle applies to concrete. Let's change it to concrete. As you can see here, I have my concrete standards as well as my database. Now, just in the interest of time, instead of having to sort of individually create all my different sort of steel types or define my different steel types, if you actually have like a past project, say for example with a certain steel or section type that you want to use for a project that you're working on currently, what you can do is you can actually just import the properties that you've created previously, which can save you a lot of time, especially if you have a particular section or material type that you sort of typically use. So what you have to do is you just go to this option here, Import, and then you just search through your computer or through your files for the model file that has the material or section type that you want to use. So let me go back here and let's see. Let me see if I can find my file here. It's Daryl, that's me. Go here. Okay, so here I have like a completed arch bridge. So this is the project that I'm working for or working on. So let's go. Looks like this one. As you can see, I have two steel types, A36 and A572-50. So we'll click OK. As you can see, they're imported now into my Properties menu. And if I look to the left here under the Works tab, as you can see, it's just beginning to become populated. I now have a Properties tab as well as a Materials sub-tab with my two material properties. If I go here under Modify, I can check to see what they are. Steel, ASTM-S, A36, perfect. Okay, so now that I have my steel types that I want to use, next I go to my section. As you can see, I don't have any sections populated yet, but if I go to Add, as you can see, I have these main tabs here that allow me to select the section type that I want to create. So if it's just a very simple section type just found in the database, as you can see, I have my basic I section along with other different sort of shapes. I have my box section, my T section, my pipes, etc. So all the major, the basic shapes are here. Now, if you have something, I guess maybe more sort of specific in mind, what you can do is you can go here to steel reinforced concrete for all your sort of composite type sections, your combined sections. If you have sort of two sort of sections that are modeled on top of each other, pre-stressed concrete. As you can see, I have like my box girders. So I have different cell types. Tapered sections, if I have a section that sort of changes dimension over a certain axis, I can define that taper here. And of course, composite sections, so if you have like a steel or a concrete girder with sort of a concrete deck or slab, it's going to be poured on later. You can define that over here under composite. So what I'll do for the sections is I'll do what I just did for my materials. I'll just import the section properties that I need. So just go to Import here, and then I'll select the same file, Progress. As you can see, I have all of my sections defined in this file. So main girder, crossbeam, arch, etc. Just click OK. As you can see, my work window is starting to become more populated now. If I go to main girder, my crossbeam, arch rib, etc. So all of my sections with their corresponding dimensions are imported now very seamlessly. Okay. So now that I have my materials and my properties created, now I can start sort of defining my model. So if I go sort of to the top left here under node element, these are all of my sort of my properties or my functions, excuse me, that I can use to create my different my nodes or my elements. But what I can do actually, since this is an arch bridge that's sort of symmetrical, I can actually use sort of a shortcut. So if I go here to structure under the wizard section, these just have various shortcuts that are available to you for example, suspension and cable stay bridges are sort of more advanced, but even base structures here. For example, I want to create an arch. I would go to the arch tab over here, and keep in mind that if you have like sets of beams or columns, etc., trusses, plates, you can use these wizards. So this is another thing that really sets Midas Civil apart, is that you can use these wizards to really cut down on the time it takes to make maybe sort of larger scale or more complex models. And sorry, just give me a second here. I think put that over here. Okay, sorry, I just needed to change my format here. Okay, so going back now, what I'll do is I'll create my base structure. I'll create this arch. And now I just need to enter in my dimensions. And before you do so, it's always a good rule of thumb to make sure that your dimensions are sort of consistent with the data that you're entering. So if you need to change your units at any time, just go to these drop-down menus. And as you can see, you have everything from meters, inches, feet, etc. So you can model your project in either SI or English units. Same with your sort of load properties or your weight properties, excuse me, your weight units. So we'll keep it in meters and kilonewtons for now. So let's create our first arch. So what we want to do is for the total number of segments, we'll leave it at 10. So we have sort of 10 segments. And then for the span, the total length of the span, let's make it 50. And the total height of the span will be 10 meters. So as you can see, it's taking shape in this window here to give you sort of a preview of what it's going to look like. For boundary conditions, let's put none. So as you can see, the boundary conditions show up as well. So I have pinned, or I have fixed, I have pinned, and none. What I'll do with the boundary conditions, I'll input them manually just so that you can sort of see how that's done later on. And then for material, let's select A5757250, and then for my section type, I'll select the arch rib. Now the insertion point, if we go here, will just be the origin right here, 0, 0, 0. And then let's click on OK. As you can see, so this is an overhead view of the arch. If we go here to the top right, we can see what the sort of the side view looks like. So here's our arch. As you can see, it's like 10 segments, and each of the length of each is about, I think 10 meters long. I can't remember offhand. But anyway, now that we have our first arch created, let's go ahead now and generate the hangers. So the hangers are just those elements that are coming off of each of these nodes here that are connecting the arch to the deck of the bridge. So in order to create our hangers, there's different ways that you can go about doing it. What you can do is you can go to node element, and what you can do is you can create these elements individually, but the thing is, like, you'd have to sort of go in and enter the coordinates in sort of manually, and that could take a little bit longer. I mean, you could do it, but there is a really great shortcut that you can use, which I'll show you. If you go to extrude here, this function, what the extrude function is, it allows you to create your elements, or create a series of elements from a certain sort of number of nodes or a number of points. So as you can see, you have here under extrude type a node to line element. So what you're telling the program is that you're going to be creating a line or a beam element from a specific node. And once you select this sort of option, it's just up to you to tell the program what direction it's going to be, what material it's going to be, how long it's going to be, etc. So what's really useful about this function is that you can make an extrusion for sort of several elements simultaneously, which can really save you a lot of time. So let's go over here now. So, oh, and by the way, different extrude types are available here. So line to planar, planar to solid. Actually, I won't go too much in detail about these later on, but just keep in mind that if you have sort of larger scale, sort of more complex models, these two functions are especially useful, especially if you have like larger sort of 3D models where you need solid elements. But anyway, let's keep it simple for now. Let's go to node to line element. Element type is a beam. And let's see, the material type will be a 572-50. And then the element type, let's select hanger. And then the next thing we need to do is we need to make sure to select the project option. So what Translate will do is it'll actually just sort of move an object over. It'll copy it. But if you use project, it'll sort of generate it off a certain point, which is what we want here. So as you can see, when we select project, this parameter, this input menu sort of changed. What it's asking for now is sort of the line of the projection that you want it for. So naturally, you want to use the project on a line definition. So we're going to select a point, and from that line, we're going to create a sort of a series of beams, or a beam. And then for our baseline definition, what we want to do is we want to just click in here, and as you can see, when this turns green, this means that the program is waiting for you. It's waiting for you to select sort of the points of interest. So let's see. So we'll select node 1 here for our first point, and then this will be our second point. So what we're telling the program is this will be a specific sort of cutoff point for all of the extrusions that we make. So just sort of try to imagine just a line being created here that's sort of a cutoff for all of these elements that are being created. So the program knows not to create the elements past the point that we specified here by clicking on this baseline definition. So that's essentially what that baseline is. It's a sort of a cutoff point for your extrusion. Okay, so now we should be ready. Let's check it out. Let's click apply. Whoops, oh, and so I forgot to put in the direction. Or actually, I forgot to select my nodes. So let's go here, and if you want to select a node, just go here under the select by window function, and then just box in the nodes. Whoops, let me unselect that. So what we want to do is we want to sort of extrude from these nodes. So just select the nodes that you want to extrude from. So what we'll do is we'll select these. Okay, so we're all set. Okay, so I accidentally selected that last node there. So let's try it one more time. So just select the nodes in the inner part of the arch. Okay. Okay. All right, so hold on a second here. I just need to make sure the beta angle is correct. Okay. That's normal. Okay. There we go. Okay, so the thing is, what you need to do is you need to select these nodes first before you put in that baseline. So that's my mistake. So just make sure, when you're doing this on your own, that you select the nodes that you want it to extrude prior to selecting your baseline. So that was a sort of a mistake on my part, so my bad there. Okay, so as you can see, now we have sort of the main sort of shape, or the main sort of, sort of the shape of our arch, but we only have one of them. So what we'll do later on is we'll actually sort of create a copy of it to create the other sort of side of the bridge. But the first thing that we need to do is we need to sort of create that bottom portion there. So what we'll do is we'll generate the main girder now. So in order to generate the main girder, what we'll do is we'll just do it very simply by going to create elements, and then we'll select the type of material that we want to use. So same as the other ones. And then what we'll do is we'll select main girder for the type. And then all you have to do is go here to nodal connectivity. And then what you'll do is you'll just go from this end to the other end to create your different, your sections. So we'll go across very simply. And as you can see, now we have our main girder lined up there. Okay, and this is the sort of the isometric view. And by the way, if ever at any point you want to sort of rotate your model, just hit down on the control button and then just use your mouse here to use the rotation. And then also, if you use your scroller on your mouse, you can zoom in and out. Okay, so let's say I sort of lost it there. What I need to do now is, if you want to sort of reset your view, just click on this arrow here to isometric, and it'll take you right back. Okay, so now let's go back to our side view, and now actually let's create a copy of this. And actually, let's go to the top view here. so that way we can select everything a little easier. So let's say, for example, we want to copy this arch frame. What you would do is you just go here, or actually go to Translate. So as you can see, notice how we're still under the Node Element section. So all of our main modeling functions are here. So let's go to Translate Elements under the Element tab. So Translate is just another word for copy. So just go to Translate. And as you can see, once you do that, this input menu to the left here changes. And another thing to know, let's say, for example, you want to check your work window for whatever reason. You want to get out of this tab. Just click Close. Click on the work window, and you can see everything that's created. So once again, we're going to translate or copy this arch here. Just go to Translate, and then Translate Elements. So what we want to do is we want to select everything. So what you can do is you can sort of box everything in like this, and everything will be selected. And let's say you want to unselect everything, you can click on this option here to unselect it. Now let's say, for example, instead of having to box everything in, what you want to do is you want to select everything very quickly. You can click on this option as well, select all, and then everything in the work window will be selected for you automatically. Okay, so now let's copy, or let's translate this. So as you can see, we're under the translate function. So what we want to do is we want to translate a certain distance. We want to translate it in the y direction. So what we'll do is we'll go here, and we'll just type in, I think the width is about 14 meters. So we'll type that in. We only want to translate it one time. Okay, equal distance, so that should be good. Click Apply. So you can't see it yet, but if we go here, as you can see now we have two identical arches. Okay, so that's how you use the arch function, or excuse me, the translate function. So as you can see, what we want to do also, let's say for example, once your model starts becoming larger, these elements will sort of start getting in the way of your view. So what you can do is to sort of make things easier to see is you can change the view to the hidden view, or to the beam diagram. So just go to here to View, and these are all of your display options, and click on Hidden. And as you can see, it'll just show you just the line diagrams, or the beam diagrams. Okay, so now let's move on. And now let's generate the cross beams. So this is another very sort of simple process as well. Whoops, let me go here. So to generate your cross beams, just go to Node Element, click Create Element. Or actually, let me show you another sort of function that you can use instead. Let's go to the extrude function again, to extrude element. And what we'll do is we'll do similarly to what we did for the hangers. We'll extrude a set of elements from our nodes here. So, for the type of element that we want to do, so it'll be similar node to line element. It'll be a beam element once more. So it'll be A36, but this time it'll be a cross beam for our section type. And then make sure project is selected. So we don't want to copy, we want to project from a line, or from a node, excuse me. And then what we want to do is we want to assign the baseline definition. Oh, and actually, so before I select my baseline, so I'll have to select my nodes first. So let me double check something quick. So 1 to 22. Okay, so what I'm doing now is I'm just checking the node numbers. So what you can do, once you create any node or element, it'll automatically be numbered. So what I'm doing is I'm just checking the numbers here. Okay. So for baseline, or excuse me, the nodes that I want to select will be sort of that top set there. So what I'll do is I'll select these individually. Okay, and now I'll select my baseline. So go here, we'll select this end to this end, like so. Click Apply, and as you can see, all of our elements have been sort of extruded, and that baseline was the cutoff point. And then just to make sure that we have the right element, or excuse me, the right section imported there, or created there, just go to View, turn on Hidden. And as you can see, those are our those are our cross beams, so we use the right section. Okay, and let's say, for example, if at any point you want, let's say you accidentally put the wrong section in. So let's say, for example, what you can do is you can select all of them just by selecting this option here. You can actually change them. So let's say, for example, I want to change this from the cross beam to the hanger section. Just select all of them, and then just drag and drop this over here, and you can change them all simultaneously. Okay. And now let's say, for example, you want to undo something. Let's say, okay, whoops, I made a mistake there. I need to undo it. Just go to this arrow over here, and you can undo your last step. Okay, so that's as you can see, if you make any sort of mistakes on the program, it's very, very simple to undo them. And another great thing you can do is the program actually has all of your sort of major steps listed here. So let's say you need to go back maybe 4 or 5 steps. You can undo everything up to a certain point. Okay, so now let's move on, and let's generate the bracings. So let's create the stringers or the bracings. So go to Elements, go to Create Elements, and let's actually, what we'll need to do is we'll need to create sort of a series of nodes going down the center here. So we'll need to make sort of a split here. And to make things easier to see, let's change the view to with a beam diagram, and then let's take an overhead view. Okay, so now we see very clearly just the overhead view. Okay, so now let's create our elements here. And what I'll do is I'll go to, make sure it's A36, and I'll select bracing. Okay, and then make sure the beta angle is 0 for your angle, and then element in the intersect field. Okay, good. And then another thing you need to do is, if you look to the bottom here, as you can see, you have 2 numbers, 1 and 2. So that represents 1/2. So that just represents sort of, as you can see, if I move my cursor over these bars here, or over my beam elements, it automatically goes to the center. And, oh, sorry, hold on a second. Let me just adjust something here on my computer. Okay. Oh, I'm sorry. I see someone said that they can't hear. So one of my colleagues, he'll help you out. But just in the interest, I think everybody else can hear me pretty clearly. I haven't seen any other complaints. So yeah, if anybody else is having issues with the audio, just type into the chat box, and we'll address you guys sort of individually. Okay. So yeah, sorry about that inconvenience. Okay. So going back to just the model here. So if I go here, as you can see, I can sort of automatically divides, or automatically goes to the center of the elements, and I can change this to 2/3, 3/4, etc., and it'll cut it to 4ths or by thirds. So just make sure that this default or the setting is set to 1/2 so you can divide appropriately. And at this point, all you need to do is go right down the center to create your stringer going down there. So we'll go straight across. And then, as you can see, now I have my stringer going through the center. And it's always a good rule of thumb to double check just to make sure that you have the right element created. Okay, so that looks good. So now what we'll do is we'll create sort of the bracings going along the deck of the bridge as well. So let's turn off the hidden view, or turn on the hidden view. And what we'll do is we'll create the bracings on the floor plane. So let's actually go to Create Elements. Here, go to Create. So we'll select A36 for our steel type again, and then bracing and string only will stay the same. And from this point, all we need to do is draw our bracings going sort of in a diagonal direction here. So this is, very simple. We'll just go like this. And as you can see, I'm creating my bracings as so. Okay, so as you can see, I've created my first set of bracings. Oh, whoops. Okay, maybe I didn't. So let's actually undo that. So actually, a good rule of thumb, actually. So as you can see, the reason that I had a bit of an issue there was because with the overhead view, I accidentally selected that top node instead of that bottom node. So what we can do actually is we can just make sure just to select these bottom portions here. So how do we sort of deactivate these top portions? What we could do actually, now to make it more simple, instead of deactivating these arches, we can actually just go across from this view and to create our elements. But just to so I can sort of show you how to create or to select a sort of a specific set of elements. Let's go here under Crossbeam, and bracing and stringer. So we'll select these, and then just go to Activate Only, go to View, and then select this option here, Active. So what this will do is it'll just turn off everything except for the elements you have selected. So as you can see, these have been selected because we still want to see those. Click on Active. Now these are all sort of, what's sort of showing. So just go here to top, and now we can go to Create Element. Make sure we have the bracing and stringer option and this type of material, or this type of steel. And we'll continue on here. Okay, and we'll just create our bracing. Now I'll just go in the opposite direction here. Okay, so there we go. And then we can turn on everything else just by clicking on the Activate option, Activate All option. So once you have everything you need created, just go here to Activate All. And now I have my entire bridge is created, or excuse me, is visible. And then let's click the Hidden View, and everything looks good as far as the bracing. So all the right elements have been used. Okay, very good. So now let's move on to our next section, which is creating the creating the bracings on the top of the bridge. So this is also very simple. So we'll stick in the create element function, and then we'll just change this to or change the section type to a strut, and then we'll just model simply from the top of the bridge. So I believe it's the third one over, 1, 2, 3. And just make sure that you have the right node selected, because it can get a little tricky with a 3D view. Oh, whoops. There we go. So actually, let's zoom out. There we go. So now we can see a lot more clearly what we're connecting here. There we go. And then check the overhead view just to make sure everything's in order. Oops, looks like this piece over here. Let's see. Aha. So let's actually undo that last one. And that's why it's always good to sort of deactivate the elements that you need or that you don't need, so you can get a better view. But just in the interest of time, I'm just going to sort of do this by hand for now. So now you can see clearly, just to make sure that all of your elements have been lined up properly. So that looks good. There we go. Okay, so let me bring back the isometric view, and let's keep the hidden view so we can keep a sort of a clear view of our bridge here. Okay, and now let's just create the strut. So as you can see, what I want to do is I want to sort of create these struts going down the center, but just to make things easier, let's actually deactivate the rest of the bridge. So let's go here, and let's just activate that only. Now let's go to the overhead view. So now you can see we can very just easily create our bracings here, because all of the other elements are deactivated, so we don't have to worry about sort of accidentally sort of putting them or assigning them to the wrong node. Let's go to Element, go to Create, and then for the type of element that we need to create, let's create a bracing, and then simply create the diagonals. Here we go. Okay, looks good. Now activate everything. And we'll activate all. And here's our bridge so far. So far so good. Oh, and actually, let me turn the hidden view. So let's actually create the sort of the centerpiece as well. So let's activate that. And let's create that element too, and going down the center. Let's go to Element, Create, and then make sure we have the right option, bracing and stringer. And then we'll go down the center. Okay. As you can see, it follows the curve as it should. And then we'll turn on everything. And there we go. So that's just the, whoops, let me go back here. That's just the basic sort of framework of the bridge. So as you can see, just using these functions, it's very simple to create the geometry that you need. Obviously, there's sort of several other shortcuts, or many other shortcuts available in the program. I just went over the basic functions for now. But I hope up to this point you have sort of a better understanding of how easy the program is to use. Essentially, what you're doing during your modeling of your geometry is you're just working off of these three tabs, or these three tabs over here. Yeah. So node element, all of your main sort of functions can be found here. As far as creating your geometry. So now that we have our geometry created, what we'll do is we'll just define our boundary conditions. So, let's say, for example, I have sort of different boundary conditions for each of these edges here that I want to create. What I would do now is I go to the Boundary tab, and I would go to this icon here, Define Supports. So click on that, and then just select the node that you want to assign the specific sort of boundary condition to. So what we'll do is let's select this bottom node here, this corner node, and let's assign it let's restrict everything in the directions, and we'll leave this free. So that'll be our first support. Click Apply. And as you can see, when you do so, this little green box shows up. As you can see, some parts are shaded in black and some parts are shaded in green. So the parts that are restricted are shaded in green, whereas the parts that are free are shaded in black. So just to give you sort of a contrast view, what I'll do now is I'll select just that top corner node here. Let's say for whatever reason, you want to assign this a different sort of support condition. Let's say for this one, you just want to restrict it in the Y and the Z direction. We'll leave the X free. So we'll click Apply. And as you can see, the X direction is free, whereas the Y and the Z, and let me rotate here, have been restricted. So that's a good way to sort of visually, or at a glance, to see what your boundary conditions, what the restrictions are. And then if I go, let's go to the end here. Let's go to these end nodes. And let's assign a set of material properties, or excuse me, a set of boundaries for each of them as well. So let's go here. And let's say for this one over here, I want to restrict the just the X and the Z direction. So we'll turn this off, we'll turn this on, Apply. And as you can see, how the sort of the shading changes along the axis for each restriction. And then if I want to do this one here, and if you accidentally select the elements, don't mind, you can only really define supports or boundary conditions for nodes anyway, so that's not going to affect anything. So for this one, I just want to restrict it in the Z direction. Just click OK, Apply. And as you can see, that bottom square here that corresponds to the Z direction is the only one that's shaded green, because that's where the restriction is. So that's essentially how you create your boundary conditions. Now if I go to, if I close this, and as you can see, now my work stream menu is really starting to get populated here. Here I have my different boundary supports, and I can close these, or I can expand these and collapse these as I need. So I collapse it. So I have my different sections and materials, etc. And if for whatever reason you need to select maybe just a certain set of materials or a set of sections, if you click here, as you can see, my main girders are automatically selected. Same with my cross beams, my arch ribs, my hangers, my struts, and then my bracings as well. And then same, let's say for example you want to select just a specific material type, you can select A36. These are all of your steel with A36 properties, and then here's your steel with all the other properties. So that's a good way to sort of make sure that everything has been assigned properly, or if you need to select a specific set of elements or materials, this is a good shortcut for you to use. Okay, so now that I have my supports, my boundary conditions put in, another thing I want to do is I want to put the boundary conditions for my beam end connections. So what I'll do is I'll just go through just a quick one, just in the interest of time, because this part's a little bit tedious, but it's really important to go over. So what I'll do is I'll go over just sort of part of doing the beam end releases. Just because if I do the small part, I mean, it should be pretty clear how to do sort of the rest of it. So to do beam end releases, just go to your boundary tab and go to beam end release over here. And then under the options here, make sure this is add or replace. As you can see, here are your different restrictions, etc. So let's say, for example, I just want to select the just these bracings or these hangers here. What I can do is I can change my selection filter. So what I can do, let's say, something that all of these hangers here have in common is that they're all sort of in the Z direction. So let's say I want to only select elements that are sort of within, or that are in that direction. Just go here to the selection filter and change this to Z, and then under the section property option, or go here, we'll go here to element type, we'll click section, we'll add, and we'll select all. So we have this to Z, so just select all. So as you can see, these are all selected now because they're in the Z direction. And then what you can do is you can just apply the sort of filter, the beam element releases that you want, so by clicking here. So you can do pinned, pin fixed, fixed pinned, etc. So for this one, let's select partial fixity. So we'll just select fixed pinned, and then just click apply. And then as you can see, sort of harder to see. Let me sort of zoom in here for you. Your beam end releases are over there. Okay, so it's sort of hard to see, but you can see those sort of green dots here that represent your beam end releases. And then you do the same things, or you do the same sort of follow through, the same process for your other beam end releases on the other parts of the bridge. So essentially what you do is you'd select the elements that you need the beam end release to be applied to, and then you'd use this option here, use this function to ensure that the right sort of releases or the right types of fixity are being applied. Okay, so that's just sort of the general overview of it. And once you're done with this filter, make sure to click it back to none. Otherwise, you won't be able to select anything except for these hangers here, because they're in the Z direction. So make sure to after you're done with the filter, make sure to turn it off so that you can select everything else. Okay. So now that I have my beam end releases created, let's create what's called a beam group. So let's say, for example, near the end of as I'm creating later on construction stages, or I need things to be more organized, I might want to organize these sections here into certain groups so that I can call them up very quickly. So in order to do that, let's go to select identity or select elements, and this function here is just what's used to select a specific type of element or function. So if you just click on this icon, what it has here is this filter here, and it allows you to select all of them just sort of simultaneously just by selecting the one that you need. So under element type, let's go here to section, and then as you can see, here are all the sections that you've defined. So let's say we just want to select all of our cross beams. So as you can see, they're all selected there. And what we'll do now is we'll just activate only these beams. So as you can see, there they are. And then what I'll need to do now is just go to our group tab. So as you can see, the tabs just listed here next to the works tab. So under structure group, let's create a new one, and we'll name this crossbeam. Enter, and then just select. We'll just window all of these crossbeams here, and then just drag and drop the name into the work window. As you can see, now all of these cross beams are in this group, and you can do the same thing with all of your other sort of elements. So later on, if you have, for whatever reason, you need to make a set of groups just to make things easier to find, it's especially used for large scale projects. You can create all these different groups, and then you can just sort of show them, or you can select them very seamlessly using this option here. Okay, so now that we have a group created, and you'll see later on just during C.Y. Young's presentation specifically why this is useful. He has a very sort of larger scale project. So now that we have our group created, let's move on to creating our load combinations and our loads. So let's go here, and let's activate everything again. Or actually, let's leave this deactivated for now. Okay. So in order to enter our loads, first let's start off, before we enter our moving loads, start off with something simpler. Let's just create our dead loads. So if you go to the load tab here, you go to static load cases. Let's create our first sort of set of loads. So let's name our first set dead load, and just select and then under the type, just select dead loads. As you can see, all of your various load types are available here for selection. Dead loads right here near the top, and we'll add that for our first set. And for the next sort of load we'll put our sidewalk load. It'll be another dead load, so just click add. So now we have our first two loads created. So later on when we sort of create or we're defining our loads, we just have to select the case that it corresponds to, or the name that it corresponds to. So that's a good rule of thumb. Before you create or before you define your individual dead and moving loads, etc., just make sure to have all of your load types listed here, so that way you can assign them very easily. Go to works. And as you can see, now I have a section here for my loads. So as you can see, as you continue to progress with your model, this becomes more populated. It's very easy to sort of go back and to make your checks here, just to make sure everything is in order. So that easily just organizes all of your information, all of your data. Okay, so now that I have my load cases created, let's define the static loads themselves. So actually, just to get a better view, let's activate everything. There we go. And then let's go to, well, let's define our dead load here. So let's go to select identity. So we'll select a certain number of elements or a certain type of elements. And then we'll go to section. And then let's select just the main girder. So because the dead loads will be applied along these girders, let's select these only. So just go here to main girder, go to add. As you can see, they're selected here for you. So now our next step would be to just define our load. So under load here, just go to uniform loads. So it'll be, I believe, element here. And then go here. As you can see, you have your load cases available. So let's select dead load for the first one. And for the first, so here, global Z. So you just want to make sure that the load is acting obviously in the Z direction. And now I just need to enter in just like your values. So let's go to, so let's make this 0 for the dead load. Let's just make this 1 just for the weight. And -90 for x2, and just click apply. Actually, it might be easier. Go to relative, and then no for the projection, global Z, very good, uniform. There we go. Okay, and then you just apply it just using this function here. So x1 and x2, that's just sort of determine the position of your loading, so the start and the end position, and then weight is just obviously the weight of the load itself. So that would be how you would apply these loads here. Let's see if I can apply it now. There we go. Whoops, and I put them in backwards, so let's undo that. There we go. Let's select these beam elements again. Go to section, go to main girder, add, there you go. So as you can see, the distributed load has been applied to those edges there. So now the next thing we want to do is we want to create our sidewalk load. So just go here, go to sidewalk load, and all of this stays the same except for the magnitude of the weight. So for the sidewalk load, let's make it -6. And, keep in mind that these are in kilonewtons. So if you want to change the load units, just make sure to do so before you apply it. Click apply. Oops, and just make sure to select your element again. So go to section, go to main girder, go to add, close, apply, and now you have your distributed loads being applied along the side there. So now that we have our distributed loads applied, let's define our moving traffic loads. So the first thing that we need to do is we need to define our traffic lanes. So if we go under load here, as you can see, we have all of their different types of loads, and then seismic load I'll be going over next week on Tuesday. So we'll hold off on that for now. But now let's go to our moving load. So click on this. As you can see, when I do so, this input menu or this ribbon menu changes. So before I can go any further, first I need to select my code. So let's go to AASHTO LRFD. And now that that's selected, I have this whole sort of, all these icons specifically for AASHTO LRFD loading. So like I said, let's go to traffic line lanes first. And what we'll do is we'll add, let's create, I think, 2 lanes. So first let's enter lane 1. And actually let's change the eccentricity, or let's change the units to feet. So what it'll be doing is you'll be selecting a certain reference point, and then from that reference point, this A section or this A parameter, that's just the eccentricity. So what I'll do, let's make this first lane -11.5. And what I'll do is I'll select crossbeam, so it'll do it with reference to these crossbeams I've created. And then for my selection, actually let's go here, moving direction. So this is just I'm telling the program that directions as far as vehicles is moving in both, and I can make it forward or backward depending on what the input I select. And then selection, we'll just leave it by 2 points. And this just allows you to select 2 points for the reference. So this is what your start, and those are what those 2 points represent. So just click in here, and once this turns green, it's just waiting for you to assign the points. So you can enter in the coordinates manually, or the easier thing to do would just be to click directly on the bridge, directly on your model. And as you can see, the arrows being created, and then select one end to the other. Okay, and then when I do so, as you can see, I have the all these different elements, my cross beams, and the eccentricity. So now let's click OK. Now as you can see, there's my first lane. And now I would just do the same thing for my second lane. Just go here, let's type lane 2, and then eccentricity for this lane would be 35 feet. Once again, we select cross beam, and then we just go by our 2 points again. So moving direction, it's both once more. And then our selection by 2 points, so we just select this first point here. Whoops, make sure to click in this box here before doing so. So I'll click on this point here, then the second point. And as you can see, the eccentricity is all listed here. And click OK. And now I have my second lane. So now that I have my lanes defined, my next step would be to define just the loads themselves, or the loads that I'm going to apply to the lanes. Let's go here to close, and as you can see, I'm going from left to right, so everything's organized in the sort of order that progress is made. So let's go to vehicles, and just keep in mind that traffic surface lanes, it's just a different option that's available to you to create sort of lanes. I'll go over that during a later time, but traffic line lanes for conventional type bridges is usually the easiest way to define your lanes. So if we go here to vehicles, first let's add our first standard. So AASHTO LRFD load. Okay, so this is I believe a truck standard. So these are just the default values, and let's leave them for now. Dynamic load allowance, let's make it 33%, and we'll click OK. And then we'll add another standard for cars, so TDM for cars, and once again the the value will be 33% for dynamic load allowance. And also, before I move on, just keep in mind that if you have this very specific sort of moving load, sort of like larger trucks, go to Add User Defined, and as you can see, you can create your own truckloads here, train loads, as well as permit trucks. So just keep in mind that you aren't restricted to just these two standards, or these two types of standards anyway, for your moving load. You can get more detailed by using this function over here. Okay, so now that I have my vehicles sort of defined, my next step, would be to define my traffic, my moving load cases. So let's go to load, and then moving load cases, and let's add our first one. So add, and we'll name this MVL. And then you could write any sort of type of description that you'd like, but let's just leave it empty for now. And as far as the number of sort of loaded lanes, a scale factor, etc., you can define them here. So for a scale factor, let's leave this as 1. And then the minimum number of loaded lanes, it's 1. Okay. Actually, let's add this first one here. So now we have our first subcase. So the max number of loaded lanes. Let's make this 1, or excuse me, the minimum number of loaded lanes, and the maximum, let's make it 2. And the lanes that we want used, let's make it just both of them. So let's select both. And just keep in mind that this is for the car load. So we have to do the same sort of process for your trucks as well. So that's my moving load case, and then what I'll do is I'll add another one. This one specifically for the truck, and then I'll do the same thing. Minimum number of loaded lanes is 1, maximum is 2, and then I'll select both lanes. So both of these lanes are being loaded by this truck is what I'm telling the program. So there we go. So now that that's done, I have my loads. I have my loads defined. So just click OK. So there's my moving load case. Okay, so that's essentially just the main, or just the overall sort of gist of moving load analysis. There's a couple of other options that are available to you. Let me see if I think we have maybe 5 more minutes, so I'll just go over one last portion before we wrap up. So let's see here. So if we go to analysis, and then analysis control under moving load, here we can make sort of go over the finer points of our moving loads. So if we want our analysis method, the kind that you prefer, exact, pivot, or quick, load point selection based on the influence line dependent point, or all points, number of line elements, etc. So it's always a good thing to do before you run your moving load analysis, just to go to this option here and just make sure that all of this criteria meets specifically what you're looking for. So those of you that have very sort of specific needs as far as it's sort of truck or lane load options, you can use these as well as influencing generating points, and you can use these functions specifically to I guess fine-tune your model. Okay, so that's about it for this session. Once again, if you have any questions, just send us an email, and we'll make sure to get back to you. You can reach us at ts@midasuser.com, and we'll be able to sort of field your queries from there. Hopefully this has helped you to sort of get your feet wet, or help you get started with understanding how Midas Civil works. I know there's still obviously a lot more to learn, but this is definitely a good place to start. So once again, if you have any questions, feel free to email us. I hope you guys found this useful. If you have any feedback, maybe things you'd like to see in the future, feel free to let us know about that as well. For those of you who had issues with maybe your audio, this session is being recorded, and we'll make sure that the recording, the audio for the recording anyway, is clear. So if there's anything that you want to sort of review or backtrack, just keep an eye out for the recording. We'll be posting it soon, so you can go over just a step-by-step process of making this tutorial, or making this bridge. So thank you again for your time, everyone. I hope you've all found this useful. We look forward to next week's session. We'll be going over seismic loading, as well as the steel design module, and then on the 27th, C.Y. Young, he'll be going over the Kentucky Arch Bridge that he created with Midas Civil. So thank you again for your time and attention. I hope you all have a good rest of the day, and we'll keep in touch.